Welcome to a lecture, Electrical Energy Conservation and Auditing. Till date, we have discussed the method of what is the scenario of electrical energy, present scenario of electrical energy in India. What are the different options are available uh, for the energy securities. Next is we have seen the energy conservation and energy audit and conservation. What is the importance of energy conservation? Audit, what are the different scope in the energy conservations, and the next point which we have already discussed is the energy management, power factor improvement, power factor management, demand side management, and all these things. Now we are going to consider the energy conservation in motive power, electrical load, motive power, lighting load, ACs, and transformer, and energy efficiency in the machines. So if you visit any type of industry, we find that there are number of motors are we are using for the different application. It may be crane, hoist, lifting machine, conveyors, or grinders. It may be a chilling waters. So compressors are there. Again, compressors. So motors are there. Compressed air is there. So the meaning is that there are large number of motive powers are in the industry, or we can say that the major load in the any type of process industry or engineering firm, major load is motive power. Now in the motive power there are different type of motor are used. Different motors are available based on the application. We are using the DC shunt motor where the constant speed or variable speed is needed, because in case of DC shunt motor, speed control is easier as compared to the three phase induction motor. We are using some synchronous motor for the improvement of power factor, or where the constant speed is needed irrespective of the load condition and torque conditions are there. Similarly, we are using the DC series motor and three phase induction motor. But most popular motor is the three phase induction motor. What is the reason? In case of three phase induction motor, the very first is that it is a balanced three phase load. So it will make our system balance. The power factor, working power factor of the three phase induction motor is better as compared to the single phase induction motor. The physical size of the three phase induction motor is smaller as compared to the same capacity in the single phase motor. So definitely when the physical size is small, it is easily mounted, easily placed in the combined machines. Space requirement is small, and the second is that the size is small. Definitely the cost of the machine is going to reduce. Second most important factor is the working efficiency as well as the working power factor. So working power factor or average power factor of three phase induction motor is higher as compared to the single phase motor. So because of this numerous advantage over the single phase induction motor and DC motors, we are using three phase induction motor. In case of DC motor, we have to convert from AC to DC because our uh, electrical power system distribution is a AC one, and as long as we are using the single phase motor, definitely the load become unbalanced. So there is a change in the power factor, average power factor size there. Conversion facility we have to keep. Again, we have to attend the maintenance of the inverters. Inverters, converters are there. So therefore, the three-phase induction motor is more popular, but it has some drawback. The very first drawback is that it has a low starting torque as compared to the DC shunt motor or DC series motor, especially as compared to the DC series motor. So where high starting torque is needed, three-phase induction motor has a limitation. Then we have to move to the second type of three-phase induction motor, is nothing but the slip ring induction motor. And nowadays, with the help of drives, that is the variable frequency drives, this can be achieved, that we can achieve the high starting torque at the time of starting. we can obtain the speed variation, because the speed control is quite difficult. In case of three phase induction motor, it will give the speed in a step. Either it is a 1000 rpm, it's a synchronous speed, 1500, 1800, 3000 rpm. But in between, if you want the speed, so 1200 rpm, or it may be 900 rpm, we have to use the different gears. And definitely these gears lead to the losses and maintenance toward the belt drives, chain drives, or gear systems are there. So still, even though, but the three phase induction motor is more popular because of its rigid in construction, less maintenance is needed. There is no power, there is no brushes are there, slip rings are there. Most of the three phase squirrel cage induction motor, the slip ring is not there. So the maintenance free is there. There is no, say, sparking over the brushes. So such type of motor is most popular in the petroleum industry, chemical industries, and where the some ethane, methane gases are there. So there is no such type of sparking over the brushes. So these are the advantage of three phase induction motor. Therefore, in our chapter, in our this discussion, we will consider the power conservation or energy conservation in three phase induction motor. We will concentrate over the three phase induction motor because it will occupy 90% of motive load in any type of industry. No doubt we are using DC motor, no doubt we are using the slip ring induction motor, but most of the motor is the squirrel cage three phase induction motor. So our interest in uh, the motors which is used in large quantities. So definitely, the if you do the some energy conservation, if you find the some method to do the energy conservation or power conservation, definitely we can save large amount of energy in the motive power. So now, in case of motor has classified, most of motor are the three-phase induction motor which we have discussed. It's a synchronous speed is equal to 120 f upon p. It's a quite simple because already we have learned. But just we'll take a review. Slip is nothing but the difference of speed, synchronous speed and rotor speed, which is expressed in the percentage. So it is the percentage slip, and power factor is W is nothing but the ratio of kilowatt active power divided by the apparent power. Now, motor losses and efficiency. What are the motor losses? Motor losses, as one is the fixed losses, and second is the variable loss. Fixed losses is the iron loss, which is going to take place in the rotor as well as the stator. But in case of iron losses in rotor, it's a quite small, or it is a negligible. The reason is that the frequency of rotor EMF induced is only 2 hertz or 1.5 hertz. The meaning is that the rotor frequency is slip time supply frequency. So when the frequency is very small, definitely the iron losses are negligible as compared to the copper losses. So iron losses is going to take place in the stator part, or that is the stationary part. And the second part, which is a constant, it is the windage and frictional loss. Since the motor speed is constant, if you are using for the constant speed application, definitely the speed of the motor is constant. So we will consider as a frictional and windage losses are constant. So the fixed loss, which is irrespective of the load condition, either it is going to run under the no load condition, either it is going to run in the full load condition, or any type, any load in between that one, the losses is remain same. It is the iron loss, windage and frictional loss. Where are the variable losses are there, which is the function of load. As load increases, the losses is increases, which is going to take place at nothing but the copper loss. The loss in the winding, copper winding, is equal to the square of current multiplied by the resistance. So these copper losses are going to take place in the stator as well as the rotor. As soon as we increase the load on the motor, it will draw more current from the stator, it will draw more current from the supply, and rotor current also get increases. So the rotor current as well as the stator current is the function of load, is depend upon the load condition. and it is going to vary with the load, therefore it is called as a variable losses. So it is quite simple, already we have learned. Just for the review, now it is the some typical say efficiency and power factor curve. It is the efficiency. The machine will give the maximum efficiency at somewhere 80% or 85% are there. But if you load the motor or machines more than its 80% or 85%, the efficiency get decreases. The meaning is that under such condition, the copper losses or variable losses are very high as compared to the iron losses, or it is said that it is higher one. Hence, the efficiency get decreases. Similarly, if you load the motor at 25% or 40%, the efficiency get decreases. The reason is that the domination of fixed losses are more, or the part of fixed losses become higher as compared to the output of motor. So under light load condition or either under small load condition, the efficiency of any machine is smaller. So it is recommended that we should load the motor, we should load the machine, either it may be DC motor, DC generator, AC motor, alternators, transformer. We should operate our machine up to the 75 to the 85% or 70 to the 80%. Then under such condition, it is become a economical one. Hence, economical ones, the meaning is that it will give the proper efficiency. You might seen that in our two-wheeler speedometer somewhere grain belt is given. So that is the optimal speed. If you are going to run the motor, if you are going to run your two-wheelers or four-wheelers at 20 or 35 speed, the fuel consumption will be more. Again, if you are going to use your two-wheeler more than 70 speed or say 65 kilometer per hour, definitely the again the losses get increases, or it is not economical. So economical range is around, say it is maybe around 45 kilometer to the 55 kilometer per hour is the speed. If you are taking this one constant speed, definitely your bike or your say two wheeler, four wheeler give the a very good uh, mileage, or it is a efficient power fuel consumptions are there. So the meaning is same. We should not load we should not use the motor at light load condition or small load condition, and similarly under the overload condition or near to the 101. So this is the same sir. Now what would be the losses? Percentage losses, fixed losses as the variable losses which is given by some standard. So stray losses is the combination of rotational loss and iron loss. Iron loss and rotational loss, it's also called as a stray losses. The losses and are difficult to measure with an accuracy as per IEEE standard. It has some compliance. The manufacturer comply the IEEE standard or IEC standard in the manufacturing of motor. Under such condition, what would be the stray losses? So it is recommended that up to 1 to 125 HP, the stray losses should be 1.8%. Stray losses, total losses, whatever the total losses are there, and out of that one, it is 1.8% is the stray losses. Whereas if the capacity of motor is increases 125 to 500 HP, the stray losses should decrease to 1.5%, and similarly it is 1.2% and 9.9%. So this is the as per recommendation of IEEE. This much is the losses. If the losses is more than that one, it is not going to certified by the IEEE IS standard as well as IEC standard uh, to the manufacturer. So this is the losses are there when we are going to purchase some motors, especially for large number of motors in the industry during the installation. We should see either the machine is compiled, some specification is compiled by the IEEE standard or IEC standard. Similarly, if you are going to purchase a large number of motors, uh, why we are talking about the purchase of motor? Because if you take the keen observation, or what we can say that if you just say take the precaution during the installation, definitely your energy conservation program will be very attractive. We have seen that if the machine is working, nobody is going to replace by the energy efficient motors, by replacing the proper capacity, isn't it? Now it become very difficult. So during the installation period also, during the installation of factory, we have to think toward the energy efficiency as well as the proper capacity of machine, in such a way that the machine or the motor should not be overloaded, or it should not be a underloaded. It should be loaded up to the 70 to 80%. So we have to take care during the purchase of large number of motor. When we are going to purchase large number of motor, uh, of a small motors or large motors, ask for the detailed test certificate. If possible, try to remain present during the test. It means that if you are, suppose if you are going to purchase 100 motors are there, so 100 motors order is very high, or means it is appreciable. So you can ask for the detailed test certificate of the motor. What is the no load current? What is the stray losses, full load losses, losses at 50%, losses as 85%, losses at 25%, and losses are 125, or say 110% overloading. Similarly, you can ask for the some special test. You want to test the insulation at the impulse voltage level, isn't it? You can present during the test condition or testing performance. Many times when the some MSDCL or TCL is going to purchase large capacity transformers or motors, sorry, large capacity transformer reactors, so the company engineer is going to present during the testing uh, of the machines at maybe a high voltage test lab in Bhopal, Ahmedabad or Hyderabad is are there. And nearby, we know that in the Bhopal, a high voltage test and impulse test is carried out. So during the test, we should remain, or the person or representative should remain present during the test. See the efficiency value and specified without any tolerance. So what is the efficiency has been displayed on the nameplate, and what is the actual efficiency? We have to compare. We have to see by looking at to its tolerance value. Check the actual input current kilowatt if replacement is done. If you are going to replace the machine, you have to measure the we have to measure the input current and input power. Suppose it is a 25 HP motors is there. 25 HP, the meaning is that it is the 20 kilowatt motor is there. Okay, so when we are using the 20 kilowatt, what is the input power, what is the input current, and what is the input kVA, kVAR, power factor. So definitely nowadays the portable instruments are available. When we are going to measure the some power in our practical session, we will see the one portable meters. We are also having the one portable meter, and by that portable meter, without disconnecting the motor, without disconnecting from its routine service, we can measure the input current, kilowatt, kVAR, power factor, frequency, everything we can measure of the motors. For new motor, keep a record of no load input current, power, input power and current. So definitely when we are going to purchase the motor, what is the input current, just to measure after connecting, after before commissioning, before putting into the service, we should note the input current, input power, and the no load condition and full load condition. The reason is that once we have the input current when the motor is new, after some time, if the current increases, we do not remember because there are large number of motors are there. We can compare what is the input power, what is the input current after 3 years, and what is the input current when it was new. If suppose it is taking more current, it means that there may be a jam in the, say, friction, more frictions in the bearings. Okay, it may be that there is some misalignments are there after long time, there is some loose fittings are there, okay, or if the machine is rewound because of the failure of winding, what would be the current? If there is a large difference between the input current when it was new and once it was rewound, definitely it lead to the energy losses in the system. As there is not only a single machine is there, we cannot neglect there are large number of motors in the process industry, in the any type of factories or industries are there. So if such things is going to happen in large number of motor, definitely uh, there is a much more power losses in the system. So definitely we have to keep some record. Use the value of efficiency for comparison for the confirming. Rely on the measured input for all calculation. In the energy audit, uh, we have come to one important topic, important point. That point is that if you are able to measure, don't do the calculation. If you are able to measure the power, if you are able to measure the kVAR, kWh and power factor, don't calculate, because in our calculation we are using the standard formulas. Whereas in the measurement it will give the actual reading. So we should confirm the reading from the measurement itself. Then and then it is possible to identify the losses. Then and then it is able to overcome that losses, or we can rectify that difficulties. We can overshoot these difficulties only when we are going to rely on the measured input data, isn't it, instead of calculating value. So we should measure the efficiency of machine for the comparison purpose. Now estimate the efficiency. Estimation of efficiency in the field can be done as follows. We can do the efficiency when the system, when the motor or when the machine is working in the system. Measure the stator resistance correct to the operating temperature from the rated current values, and losses can be calculated. No doubt, when the motor is running, the temperature of winding get increases and hence its resistance also. So we have some formulas already, we will see, or we will see in the later on. So we have to do the correction in the value of resistance. That is a correction. The meaning is that uh, the change effect of temperature we have to consider in the resistance value. And after calculating the effective resistance value, we are able to calculate the losses. So if you are neglecting the temperature effect, definitely the calculated values and actual power consumption will be different. Okay. So therefore the measured data is more important as compared to the calculated data. In calculation, we are ignoring the temperature. Definitely the losses computed will be smaller than the actual value. From the rated speed and output, rotor losses can be calculated. Definitely we can. From the load test, the core loss and stray losses can be calculated. So either we can do the no load test, block rotor test on the three-phase induction motor. We can do the direct loading test by measuring the input and output power. So by this way, we are able to measure the powers. Now, point selection of the motors. What would be the selection? What would be the criteria for the selection of motor? In the selection of process, the power drawn at 75% of loading can be meaningful indicator of the energy efficiency. We have already discussed that the motor give the efficiency at 80%, and we should, it is the recommended from the manufacturer, also from the manufacturer of even diesel generator set, it may be some transformer, it is recommended that the machine should be loaded up to the 80%. So the input power or efficiency should be measured at 75% or 80% loading. If you are measuring at 50%, it will give the efficiency is smaller, whereas actual efficiency at 75 or 80% is good. So we should measure the efficiency or input power at the 75%. Reactive power drawn by the motor. Definitely, if we are measuring the reactive power, it indicate either we have to connect the capacitor to the motor terminal, or we have to add some more capacitor in the center level, that is the APFC, to maintain the power factor. So how much reactive power drawn by the motor, it is very important, because by this calculation, by this measurement, we are able to decide the capacity of capacitor to be connected near to the load for increasing the efficiency. Indian standard 3 to 5 for the standard motors allow 50% tolerance on the efficiency up to the 50 HP. If the 50 kilowatt motor is there, the tolerance is a 15%, and whereas if the capacity is more than 50 kilowatt motor, the tolerance will be 10%. So in the previous PPTs, it is has been observed that the capacity of motor increases, the losses, percentage of losses should decreases, and similarly the tolerance value should decreases, because at a higher capacity motor, uh, the constant losses are smaller as compared to the small capacity motor. The Indian standard IS 8789 address the technical performance of the standard motor, while IS 12615 address the efficiency criteria of higher efficiency motors. So this is the some standard codes are there which has been specified. It will specify the what would be the tolerance in the torque, what would be the tolerance in say output efficiency or output power and efficiencies are there. So these are the IS code, it may be IEC codes are there, testing purposes, what would be the methods to be utilized, IEEE standards are there for the this one. It would be uh, okay. The energy saving by the motor replacement can be worked out by the simple relation. The KVA saving, if you are going to replace by the old machine by the new machines, so what would, how much power is going to save? It is the kilowatt output, whatever the capacity. If you are going to replace the 50 kilowatt motor, so here the 50 kilowatt is the capacity of motor, into bracket in 1 upon efficiency of mold machine minus 1 upon efficiency of new machine. So definitely the new machine's efficiency is higher one, and we will get some positive value factors is there, multiplied by the output power or the capacity of the motor. So it will give the kilowatt saving of motor. For example, on the 50 kilowatt motor, the saving is 2 kilowatt. So 2 kilowatt motor is going to run 24 hours, 365 days. So 2 kilowatt multiplied by the number of hours is a 24. So that much is the active energy or units kWh saved per day, multiplied by 365. So this is the saving, energy saving in per annum, multiplied by the rate of electricity. So it will convert into the benefit in the financial term. So by this way, we are able to calculate the energy saving or the power saving under the replacement of old machines by the new machines. So for that new machines and old machine, we have to calculate the efficiency of old machine or existing machine and efficiency of new machines. So now energy efficient motor, what is the energy efficient? What are the different difference between the energy efficient motor and standard motors? We will see in the next lecture. So we will stop here today.